Well, guys, I'm back. I know it's been a little while that we've been kind of plugging away at this and doing a few other things. We're getting close. Let's see. Where do I want to start at? Well, the first thing to notice, I get here and sit down, is the fact that we have a different transformer. Now the interesting thing is, after 80 some odd years, the other transformer decided that it didn't want to live any longer, and the primary went out of it. Now the interesting thing is when it did go out, it was at a point when I wasn't even basically making use of that one. It was still plugged in and powered up, but only thing I was doing at that time was working on the filament supply, which was off a separate transformer. So that was the only thing that was being loaded. But I don't know. I had the voltage cranked down on it, but it's still, I guess 80 some odd years, it probably maybe even drew some moisture and it finally just gave up. So anyway, I had this guy, so I put him in there, which then threw everything off, because it's B+, it's high voltage winding, it puts out a lot more voltage. So I've been in the process of trying to reduce things down as much as possible. But and we're getting close. We're getting fairly close. But I'm actually at a point now that I think the one thing I have never cleaned on this and have not actually done yet, and that is clean the tube pins and the sockets. So they are drawing current, but they're not drawing the current like they should be. Especially these three up front here, the 22s for the RF. So. And I know the pins and the sockets are pretty dirty. And I know that here a little bit off and on when I would wiggle them, she'd get staticky and make some noise. There's the infamous BH rectifier tube. It doesn't glow, but it gets warm. It gets really, really toasty warm, but it doesn't, unfortunately the type of gas they use in it does not allow for glowing, which is unfortunate. Be kind of nice. So anyway, we got it hooked up. One of the biggest problems I was running into is, unlike virtually almost every battery operated set out there from all other companies, there's a lot of different things that they do differently. For one thing, most of them will run all your tube filaments in series. They will also probably be lower voltage, at least some of them, and they are usually fairly low current draw, but run them in series allows you to have the lower current, because when you got, you can think of the filaments as resistors. When you got resistors in series, the current stays the same throughout the circuit. It doesn't change, just the voltage drops. So, but not on this radio. On this radio, everybody is in parallel like you would find in a transformer radio. And it runs off of 5 volts. Even though these are 3.3 volt tubes, they've got filament resistors. I don't know if I can show them. They're right here and here and here and here. Oh, this one here, this one, this one, and this one, this one. That drop it from 5 to 3.3. Well, what that does is it means that the currents add up. Well, these 132 milliamp, these are 250 milliamp, so is this one, this one, this one. So that, between all 7 tubes, that's 1.4 amps. But something else that most battery operated radios have in common is they use a permanent magnet speaker. Not on this one. No, in this case we have a field coil. Well, if that's not bad enough, we have an 8 ohm field coil at 5 volts. Do a little math. That's 628 milliamps. So that puts the total draw on that 5 volt line of over 2 amps. That's difficult. Now, not for the most part, most filament windings and a lot of heavy duty transformers can easily handle 2 amps. But then you run into the other little problem, is it's a field coil electrodynamic speaker that has to produce electromagnet. It cannot do it on AC, so it has to be DC. Doesn't care if it's real pure DC, but DC nonetheless. So I had to rectify it, because I could not run it on the B circuit anywhere. I mean, there's just not enough current there, not enough power there to do that. So I had to run it on the A. Well, then, after realizing that we're going to have to do that, you know, there was some choices about things, and in retrospect I kind of realized that, hey, I could have done it anyway and still ran AC to these tubes. But then I realized the way the radio is wired, it's wired for DC to the filaments. A lot of the circuitry is designed out and to operate that way, as opposed to having AC to the filaments. So I would have had to change a lot of circuitry, which would in turn mean changing the radio, and I did not really want to do a whole lot of major changes to this. So I got thinking, well, okay, I had a bridge rectifier, or I got one, and that's what's in it now, and it's back here. It's underneath this, back underneath here. It's using this as a heat sink for it. It's a 8 amp, can handle 200 up to 200 volts and up to 8 amps. It can actually surge up to 27 amps. Full bridge rectifier. Well, I thought, well, that's good. The only problem is that even though it's silicon and it's full bridge rectifier, it still drops 2 volts across it. So you go from having a 5 volt supply to a 3 volt supply at best. But that still rippled, still had hum, so it needed to be filtered. Well, I really don't have the big enough capacitors to really truly filter it good. With capacitance alone, it just wouldn't work. I put the biggest ones I got. That helped, but I could not put a resistor in there and make a pi filter, because the resistor would drop current and drop voltage. As it was, I ended up having to pull the 6.3 volt filament winding from here, put it in series with all the windings on this one, just to get my 5 volts. And I'm actually, with between the drop of the rectifier, the filtering, and then to make up for the filtering, I'm using the field coil as a choke, tying it in between the filter caps, and that's giving me around about 4.5 volts out of 5, which is plenty fine. I did check these guys to make sure that I was getting, you know, because they got the resistors on them and they're dropping down to 3.3 volts, and I wanted to make sure that since my 5 volts is not fully 5 volts, I want to know what these guys are doing. They're doing 3.2 out of 3.3, so they're perfectly fine. And I don't mind running a little less hot on the filaments, especially on these 171As here. They're globe tubes, and they're kind of hard to come by, and hey, if I can save the filaments on them, more the merrier. Now, it's a disastrous mess here. And mainly because trying to get everything back to the way it was before the transformer went out. I've got a couple resistors here that I've been playing around with. I've been able to get the 180 volts line down pretty close to 180, and in fact the only one that's out a little bit that's giving me a little troubles is the 135 volt line, which is what feeds the plates to these guys. And I think really they're operating, which I'll show you here in a minute, but it's I think just because the two pins, or at least right now that's what I'm thinking it is, that they're just not biasing up good, and the current draw is a little lower in them. So I'll do a little finagling, clean them up and everything, and if I'm still having problems with them, then I'll do a lot more deeper searching and stuff. So I haven't picked up a radio signal, but there's a reason for that, and I'll show you why. But we'll go ahead and fire up. Right now you can hear right now on the B, and it'll go up here pretty soon a little bit. Let's run around 177, 178. That's the main voltage. I'm running just feeding a signal in through here from the signal generator right into this middle tube. Now it's tuned in good, but if you watch, I'll show you a little fun thing about these. Now let's go to this one. Ooh, it's not very noisy, but what if I turn it? I can get it louder. That's about max on that one. Now if I go back to this one, it's about the same, but now if I turn the tuning condenser again, or the tuning, I can get it louder. Now what's going on with this guy? Not too bad. It's pretty close. This is how you align these. You got to go to each one of the tubes, and then you got to do the final. You would actually look at what's going on here at the detector, but you have to do that from below. And then each one of these has got set screws on them, and you get what you do is you get the primary. This is considered primary. This first one here has got the dial on it. You get it set, you get the dial set to your generator, and that sets your primary, feeding the signal into the grid there, and get it set. And then you start going through, and actually you should go this way first and then worry about the detector, the last one. And you just adjust these, loosen the set screws, and turn the tuning a little bit until it gets the loudest signal being fed in. Once that's all done, and you get this one over here done by checking the detector, then they're all in line. They're all passing your RF through like they're supposed to, and then it would pick up a radio signal. As it is, this one especially is way out, and I got a funny feeling this one is too, a little bit. So it takes some time to do, because you tweak some of them. Like I would get to this point and tweak this one, and then I'd come back and I may find that it's a little bit off. Adjust this one again, adjust that, You go through it about 4 or 5 times, maybe 6, to get it really good. It's just a time-consuming thing. But and in my little haste of doing things, and even though I took pictures and I labeled, checked stuff, and even though the wires actually got good colors to them, I think, well, of course it's not going to work now very good because I'm feeding the signal there. I need to feed it back down there. But the volume control, I think, is actually hooked up backwards because you turn it fully counterclockwise to get full volume. So let's see what else. This is the only one that's actually got batteries in it. This one just is dummied in there, and I'll probably take and just hook a wire across there and take one of these and hook over here just to make it look good. But it's got 5 9-volt batteries there, and the only thing they're biasing is the 2 output tubes. Not a whole lot else. Oh, and as far as, you know, I'll have to have, you know, rigged up some wire that'll go from the speaker to here to hook up this. And see, one of the things I was really concerned about and dilemmaed on was every time I looked at this, I kept thinking, well, I got to add wires to this cable, which is in really fantastic shape. In fact, I really like their label, which is kind of a canvas-like material. You know, it's cloth material. It's not a paper label. That's why it survived so good. And then I got thinking, well, wait a minute. The power supply is going to sit in the bottom of the cabinet, right where the speaker's at, right by the speaker. So all I got to do is disable the 2 wires here, and that normally feed this coil. Hold on a minute. I'll be right back. So anyway, I'm back. But I guess that's about where I'm at. Oh, one other thing. I'm probably going to have to, if I decide to have any type of surge protection, I'm going to have to use the CL90 in here. That, which I've actually got this shorted across right now. That thing takes forever to heat up. And at 19 ohms hot temperature, it drops a little too much voltage to the primary for everything to work the way, you know, give me the voltage I'm supposed to have. So if I put one back in there, I'll probably put a CL90 or something of that nature, because they'll heat up a lot faster. That thing takes quite a bit of time to, I mean, considering there's the amp meter. This is what this thing's drawing. That's a 3 amp full scale meter, so we're well under, you know, we're running at, you know, what, 400 milliamps or 40 milliamps there, so something like that. Or it's pretty low. So anyway, before I forget it, go ahead and shut this thing off. It's getting annoying. Changing out, getting rid of that one transformer is how you do it. Is you just drop. Here's this will be the detector tube. This is just a filter, and you go to a resistor that'll hook to your B plus. That's 100K resistor there. A 0.047. And you can play with that a little bit. I'm running for 0.047, seems to be fine for me. That just, whatever kind of tone you want. You can go up like a 0.1 if you want. And then you feed to the grid of your first audio with a 1 meg load grid load resistor. So that's all there is. You take out the transformer. So the transformer, you would have the B plus hooked here, this lead would hook up to here, this would hook to the grid, this would go, in this case went to negative 4.5 volts on one of these batteries. So, but it works good, and that's all you do. That's all there is to it. So I'm going to end this right now, and make another video when I get a little more progress done and let you know how things are going. So thanks for watching, thanks to my new subscribers, and thanks for your comments, guys. And if I don't get one done before Christmas, y'all have a very Merry Christmas, and hopefully I get one done before the end of the year. Thanks again. Bye.